Alright, ladies and gentlemen, here's a quick video on wave interactions. Sorry if you tried to watch the previous video. Apparently there was an issue with the sound, so here we go. There are 4 interactions that we needed to know about with waves, how they interact with each other in the environment. First is what happens in this image here. This is reflection. So waves come off of like the lights here. They hit the water and they bounce off. So this kind of typically what you think of as reflection. You look at yourself in the mirror, and light waves that had originally bounced off of your face hit a mirror, bounce back to your eyes so you can see your own reflection there. And this is reflection is the wave interaction. But another example we don't think of that's not visually based is if you like yell into this is the Grand Canyon, you'll hear an echo back. And an echo is just an example of a reflection of a sound wave. So reflection can happen with any type of wave, whether it's light waves, whether it's sound waves, ocean waves, anything can have reflection. So reflection is just when a wave bounces back after it struck a barrier. There's lots of different options that can happen. The next wave interaction we need to know about is what you see here. You probably noticed this at some point where you see like a straw in a cup of water and it looks like it's been broken or bent, or maybe what the parts that are in the water look like they're much bigger than the parts that are out of the water. This is called refraction. And what ultimately happens here is that light waves, as they travel through the air, are traveling in one direction, but then when they hit the water, one side, like this inside here, slows down, and the other side hasn't slowed down yet, so it causes the light to bend and change the direction at which it's traveling. That's what causes things to look out of place, or to look like they're broken like this. If you've ever tried to go fishing and you cast out, and where you throw your line isn't quite where the fish are, that's because of refraction. The fish just appear to be in a different location than they really were. Again, that's called refraction. It's the bending of a wave as it passes from one medium into another medium. Now it has to hit the barrier at an angle. Notice that this requires at least 2 different media. You have to have the first medium, like say the air, for instance, and a second medium, like the water, for instance. The reason why the wave bends is because of the different speed at which the wave travels through the different medium. In the case of a light wave, it travels faster through the air than it does through the water. So when one side of the wave hits the water, it slows down, but the other side hasn't hit the water yet, so it continues to travel at its air speed, its faster speed through the air. Next, what kind of creates this ominous situation in this image is called diffraction, and this is the bending of a wave around barriers or through openings. This is what causes that V shape of sliver of light if you're like in your bedroom at night with the lights off and then someone turns on the hall light. And a little crack in your door, you get this sliver of light that comes in and makes a V shape in your room. That's because as the light wave enters your room, it kind of bends outward after it gets through that crack in the door. How much a wave diffracts is going to be dependent upon the wavelength as well as the size of the barrier. So some waves, like sound waves, which have long wavelengths, they bend a whole lot more than light waves, which have a shorter wavelength. This is why you can hear someone that's in the hallway when you're laying in your bed at night and it's dark in your room. Someone turns on the hall light, a little sliver of light comes in, but someone talking in the hallway, that sound fills your whole room. Sound waves which have a longer wavelength will diffract more than light waves do because they have a short wavelength. So diffraction is the bending of a wave around a barrier through an opening, and it depends on the wavelength and the size of the barrier to determine how much diffraction you're going to get. The last thing we have here is it's called interference, and it's when 2 different waves are in the same exact location at the same time. There are 2 different types that you need to be aware of. 3 different types you need to be aware of: constructive, destructive, and resonance. Constructive is when you have like 2 waves, like say this is wave 1, and then you have a second wave. Let's call this wave 2, and like parts are overlapping. So like the crests are overlapping with the crest and the troughs are overlapping with the trough. So you get this new resulting wave, and the crests have combined and the troughs have combined. So my new wave, this purple one, has taller crests and deeper troughs. This causes a higher amplitude and therefore more energy in the wave. Destructive interference is the exact opposite thing. Instead of having like parts of the wave overlap, you have opposite parts overlap. So the trough of one wave overlaps the crest of another. This causes you to get a decreased amplitude and softer sounds in the event that it was a sound wave. The last thing is called resonance, and this is what you would think of like someone sings a really high note and it causes a glass to break, or if you were to stand next to this car with the music just blasting, you would feel it in your chest. That's due to the vibrations of one object causing a second object to your chest, or the vibration of one object, someone's vocal cords, causing a second object, the glass, to vibrate. It can be a destructive force. If you check out what happens with the Tacoma-Narrows Bridge, you can just kind of check out a YouTube video or something. But the Tacoma-Narrows Bridge fell, it collapsed due to resonance. And so resonance is interference that occurs when one object vibrating at a certain frequency causes a second object with the same resonant frequency to vibrate as well. And again, it can be very damaging. So that was the last video on wave basics. So hopefully you've checked them all out and you're ready for your upcoming assessment.